Welcome guys, Sizwe here, Sizwe Academy, and this is the global classroom. We're still on trigonometry, and this now is the table of cos theta graph. Check the videos, we did the table of sine theta graph. We're putting the values in a table format. We put it all down here from 0 degrees to 360. We put the radians as well. If you don't know what radians are, go and find out. Even if you don't know what these degrees come from, check our video. We explain where degrees come from, and we show you how to get these degrees. And then we come to radians and explain them as well. We are dealing with the x value, and these are ratios. It's the 0 degree ratio right through to 360 degree ratio. All these. If you don't know how to get these ratios, which we'll be showing here, it's there in our videos. Check those videos. We've got the 30 degree angle, 45 degree, the 60, and the rest of these angles. They are available there in the videos in the Sizwe Academy. Now let's get to this one. Let's put this pen there. I don't think I need it. The values for x, where at 0 degrees, when the radians are 0, the x value is 1. At 30 degrees, the x value was what? Root 3 over 2. Root 3 all over a 2. Yes, because the y value at 30 degrees is half. So this is root 3 over 2. At 45 degrees, it's root 2 over 2. At 60 degrees, it is half. At 90 degrees, the x value is 0. You see, from 90 to 0 or from 0 to 90, it's all positive, because all these quadrants, I'm talking sine, tangent, and cos. In the first quadrant, which is from 0 degrees to 90 degrees, they are all positive. When we get to 120 in the cos graph, remember the cos graph at 120, it goes to the negative. So at 120, we start seeing the negative, because cos is negative in the second quadrant. From 120 to 180, we are in the second quadrant, and cos in the second quadrant is negative. Only sine is positive in the second quadrant. So this is what it will show us. So from here, 120, it becomes negative. I need to use a different color so that you will see it's negative, because it will be like I'm extending the dotted lines, which I definitely am not. Right, so it is negative here. In fact, it's negative right up to, is it 270? Right up to 270, not 360. We'll see right up to where it is negative, right up to 270, because it becomes positive in the fourth quadrant, which is above 270. So from now here, I can safely put a negative, 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 negative 225, negative 240, and at 270, it is 0. X at 270 is 0. So let me leave it here. So 0 is, we don't put a negative on 0. And then this side, it's positive. It's above. The thing is, I'll show you just now. I'll do a sampling of the graph on how it will look like, so that you can see the positive and the negative. So right here at 120, it becomes a negative half. At 135, it becomes negative root 2 over 2. At 150, it becomes negative root 3 over 2. At 180, x becomes -1. It's -1. X is -1 at 180 degrees. 180 degrees. This is how it looks like. This is the graph and this is it. Let's say from here, it starts at 1, it doesn't start at 0. This is the cos graph. So it starts at 1, it tells us here. It starts at 1 and it comes down and it reaches 120. Here is where it reaches 120, it's here. So this is 120 degrees. At 120 degrees, in fact, here it's 90, sorry, not 120. Here it's 90 because 120 is -1/2, right? So it's 90 degrees here. And then at 120, it is -1/2. Here is a -1/2. It's here at 120. So from here, the graph takes the negative as it goes up, it goes up, it goes up until it gets here at 270. This is 270 where it reaches 0. At 270 it is 0. Maybe let me finish so that you will see, because I just wanted to show you this is the positive part of the cos graph. So from here to here, this is from here right up to here at 0. This is 1, √3/2, √2/2, half at 0. This is where at 0 is at 90 degrees. From then it takes a negative form. It goes down to the negative right up to here where it is at 270 degrees. Here it's 270 degrees. Maybe let me move this. Here it's 270 degrees. This is where it takes a 0. This table gives us a clear picture of what it looks like, but let me carry on. Here at 210, so we say 1 and then we say here it's -√3/2. In fact, here it's at -1 here. It's at -1. But it starts going up now. But it's still on the negative. Here it is. -√3/2, which is basically somewhere here. 0.866. It's here. So it starts going up. It starts going up. But it's still below the positive x-axis, which makes it the negative y-axis, right? -3/2 and -√2/2 and a -0.5. So at -0.5 here it is here, it's 240. Here it would be at 240. Here it tells you -0.5, it's 240 here. 240 degrees. It speaks on its own. It tells the whole story. At 270, it is a 0. At 270, it is a 0. Let me not use the 0.5. I don't know why I'm using 0.5 because I'm not in the decimals. I'm just, so it's supposed to be -1/2. It is indeed the same thing, but since I'm not doing decimals on others, I shouldn't do a decimal here too. So it's 0.5, -0.5, which is -0.5 at 240 degrees, and at 270 it's 0. At 300 degrees, it's now on the above the x-axis, which makes it positive because the y value also is positive now. So 300 degrees would give us a positive half. 315 would give us a positive √2/2. At 330, a positive √3/2. And at 360 degrees, it takes us back to 1. It gives us a 1. Let me put my 1 here. Just maybe let me put it closer to the 360 side, which is this side. It's 1. At 360, it's 1. It takes us back and it gives us here, it takes us from here, it takes us to the value of 1. Here is our 1. This is where we began. We said 1 is here. So my line should end here. So it takes us here. So Below this is negative, and this is positive. This part is positive, this is negative, this part is indeed positive, because it's above the x-axis, positive for the y-axis as well. So this is what the graph will look like. The x value, this is how it is. Remember when we had those figures, the ratios, this is what it gave us. Remember, we only in the cost graph, we only consider the x values. The x values, this is 1, this is what, remember we had here, like for instance here we had x is 1, y is 0. So this is the x value we are dealing with. We're not considering this because this forms the y value, and the y value is equal to sine theta. This is not a sine theta graph, it's a cos theta graph. This is it. We consider this one. Right. I hope that is clear. I'm wiping this out so that we can carry on with the decimal formats we want to use. Let me put this here. So at 1, the decimal form is 1. At 0, when x is 1, its decimal form would be 1 at 0 degrees. At 30 degrees, it's root 3 over 2, which is 0.866. Root 2 over 2 is 0.707. At half, it's 0.5. 0 would remain 0. It's minus now, minus 0.5, minus 0.707, minus 0.866, minus a 1, right? And a minus 0.866, minus 0.707, minus 0.5. At 270 it is definitely 0, and that's how we put a 0. There is no point form of 0. And then above 0, because it's going up now, it's above 0, it becomes a 0.5, and here a 0.707, a point, we bring it a bit closer, 0.866, and at the bottom it's 1. At 360 degrees it is 1. So ladies and gentlemen, this is what it looks like. The table, trigonometry table of cos theta graph. So with this given, if you have this and you know this, you can table your graph just straightforwardly, just like that. Put your graph, you follow these values, you know your degrees on the x-axis, you put your degrees on the y-axis, you put these values, 1.866, 0.7, 0.5, and 0, and then below it's a minus, below 0 it's a minus half, it's a minus 707, minus 866, and a minus 1. And then it comes back again from minus 1. Remember here at minus 1, it's where it's coming back from here. This is minus 1. Minus 1 will be here, and then it goes, this goes here, 0.8. It's starting 0.7, 0.5, and then 0 again. That would be in your graph. So, ladies and gentlemen, girls and boys, or shall I say girls and guys, this is how we have it. Let me remove this. This is how we have it. This is what makes up our graph. This is the table that gives us a clear picture. As they say, numbers don't lie. These numbers tell the whole truth. And if you want to display them in a graph form, simply do that. You can just take them as they are here, put them in a graph form, and follow their sequence as they tell. You will see the graph will come straight up because it starts at 1 and it ends at 1. All these figures will fit in their places accordingly. So thank you so much for having me. Hope this makes sense. Hope this is clear to you. Hope it gives you a clear picture of what you are looking for when it comes to trigonometry. And yeah, these are radians are just a substitute of degrees. If you don't want to use degrees, we use radians. But when we're dealing with radians, plainly radians, I will explain about radians. Why do we even have radians? Why we should use radians? What's the reason why should we even consider radians? Same as degrees, we explain degrees, radians, ratios, decimal form, cos theta graph. Check for the sine theta graph as well. Thank you guys, and God bless you.